Okay, this is page 4 of the network notes, the last one for today. And so section 3 is just about byte order. And so our working example for this is hex number ABCDEF01. 8 hex digits is 32 bits. And so each of these is a byte, or 8 bits. Hex digit is the same as 4 bits. And I'm pretty sure you've heard of little endian and big endian. It was relevant to lab 1. So with little endian byte ordering, you put the least significant bit at the lowest address. So let's just say the starting address is x. So this is going to be address x plus 0, x plus 1, x plus 2, x plus 3. So we're storing a 4-byte value. With little endian byte ordering, the least significant byte is 0, 1. So that'll go there. Then the next one is E, F, C, D, A, B. So little endian is logical, and it was used for the x86 processor, still is. Most modern processors can be configured to operate in either little endian or big endian mode. Now, if you're storing the same memory location, you're storing the data, but you're storing it in big endian byte order, then the most significant byte goes at the first address. And so it's perhaps less logical, but it's definitely easier to read if you're looking at a memory dump. And so big endian is used in, well, it was used in the Motorola 68000 processor, which is usually abbreviated M68K. That was the processor in the original Mac and used in lots of other applications too. It's also the networking byte order, which is why I'm introducing it here, but it is also the byte order used in the ping format if you've got, you know, a 4-byte integer. It's going to be stored in big endian format. And so, as you know by now, you have to be very careful about, when you're reading it from the file, converting it to the host network or host byte order before you work with it. So you always convert multi-byte integers from network order. So if you're getting data from the network and it was a 4-byte value that was sent, then you should flip it around to the host order. Or if you're sending a 4-byte int, you should flip it around before you send it. And that way, you don't need to worry about the endianness of the receiving computer, because you know they'll take it from network byte order and convert it to their host order. So we have these 4 functions that we can use. Host to network long, host to network long. So it's host byte order to network byte order, and long is 32-bit or 4-byte. Then we've got host to network short, so that's host to network short, and a short int is assumed to be 16 bits or 2 bytes. At least that's where the name comes from. And then we have network to host long. So network to host long, and again that's going to be 32 bits, and network to host short, and that will be 16 bits or 2 bytes. If you want to see this in action, I did create another server socket programming example that you can look at that does this. So I send an integer value. In this case, it is going from the server to the client. So the server sending the data. And I called that sock server.c, and then the counterpart is sock client.c. And I'm not going to go through it here. It's not that different from what's in the big send, big receive that I showed you, except that it's sending simpler data. Okay, so next up we're going to talk about curl very briefly, but we'll do that on Friday.